All right, class, happy Wednesday. I got an email from Jake, thanks Jake, that there were some questions about worksheet 6.3, question number 4. So I thought I'd go over it. So the question is this: a coin is to be tossed n times. If the probability of obtaining at least one head is required to be, that's a typo, is required to be greater than 0.8, I want you to compute the smallest value for n. So there's two different ways you can approach this. What I really meant this question was to be was kind of an exploration, kind of for you to get comfortable working with sample spaces and figuring things out. So I'm going to approach this problem two different ways. The first way I want to approach it is just by looking at sample spaces. So I want to compute the probability of obtaining at least one head. So let's say we only tossed one die. So, sorry, not a dice, a coin. Let's say we only flipped one coin. If I flip one coin, I have two outcomes, heads and tails. So what's the probability of obtaining at least one head? Well, in this case, that probability is going to be 1 out of 2, 2 being the total size of my sample space. So 0.50. Well, 0.50 is still not greater than 0.8, so let's keep going. Now I have n equals 2. What's the size of my sample space going to be? So remember, I'm flipping a coin. So I have 2 choices for my first coin and 2 for my second coin, 2 to the second. So I have my sample space is going to have 4 different outcomes. Remember, the sample size for a coin toss is going to be 2 to n, and that's where n is the number of times we toss the coin. So I had done this problem because I really want you to get comfortable kind of diving in to kind of digging through things mathematically. That's the point of this course. It's less about calculating specific correct answers and more about feeling more comfortable when working with probabilities and sample spaces. So I have 4 possible outcomes. I have heads, 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 tails, tails, heads, and tails, tails. So in this case, the probability of getting at least one head, well, that's going to be 3, because it's at least 1. I could get 2. That'd be awesome. So it's going to be 3 out of 4, which is 0.75. Still not 0.8, but we're getting really close. So let's take a look at when n equals 3. I know that this sample size is going to be 8. So I have heads, 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 tails, heads, 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 tails, and tails, heads, heads. And then I have all tails, 2 tails and a head, tails, heads, tails, or heads, tails, tails. So in this case, the probability of having at least one head is 7, because I've got 1, 2, 3, 4, 5, 6, 7 out of 8. Well, 7 divided by 8 is 0.875, which is greater than 0.8. So we have our answer. N has to be 3. But what if I wanted to approach this a different way? Let's take a look at, let's think, what would be the converse of at least one head? Well, the converse of at least one head is going to be the probability that there are no heads, right? Because you either have at least one head or you have no heads. In each of these experiments, no heads occurs only once. So the probability of no heads. Well, the probability of an event in its converse adds up to 1. So if I wanted to examine this a different way, I could say, okay, what's the probability of no heads, which is always going to be 1 out of my sample size, and then take a look at 1 minus the probability of no heads, because that would have given me the probability of at least one head. And you can just start plugging it in. That might have been a little faster because then you wouldn't need to draw all the sample spaces. But then again, it's totally up to you and how you want to approach the problem. So the final answer was 3.